So this might not be as useful as I think the Nashville number system is in color, but I still think it's a really cool thing, and it could be quite useful. So now I notice if I start on not going anywhere, that's going to be, I'm going to call it flame now. 1 is amber, 2 is chartreuse, 3 is lime, 4 is mint, and so on and so forth. So we have these colors representing the distance when I don't go anywhere, when I go 1 step up, which could be a half step, or a 1 note away minor second, when I go 2 steps up, which could be a whole step, or 2 half steps, or a 2 note away major second, 3 notes up, which would be a 3 note away major third, 4 notes up, 4 note away, this would be a minor third, 4 notes would be a major third, 5 notes would be a perfect fourth, 6 notes, possibly a diminished fifth, 7 notes, a perfect fifth, and so on and so forth. I don't care what you call it, 7 notes up or a perfect fifth or whatever, I'm going to call it azure for the color. So that means I can then look at distance-wise and say, well, if I'm going from A to B, I can name it all with color. I went from the red note to the yellow note, which is a distance of chartreuse. Now that might seem very abstract to say. I went from A note to A sharp, and the distance is amber. Again, that might sound kind of weird to say. I get it, kind of wonky, kind of like, but that also means that when I map out the fretboard, you can see everything by color in a similar fashion as we have over here. And I find that if you actually name the colors, it helps you to visualize it a lot better as well. So for example, here's a fretboard where now I have both. Here's the frets. I'm in the middle of the fretboard, 5, 6, 7, and 8. They have 2 sides to them now, meaning the first side is giving me the point measured in note name, A, and the relative position from a Nashville number system, the 6th, and the node name, A, for Aeolian. This one we're going to say is, and this is going to be the distance. So this is going to be the distance from a particular node, in this case being from the key of C. Let's look over here at the Ionian. This Ionian, this is the 7-note collection around the C major mapped out, giving us the point and then giving us the distance. So from the perspective of the C major, the C is the 4th note if I make A1, 1, 2, 3, 4, and then it's the Ionian node if we're seeing it from the 7-note collection around the C major. We applied the formula to C major, whole, half, and so on. And it's going to be 1 from a Nashville number system. Now, if I don't move anywhere, what's the distance from C to itself? It's a perfect first, or we went nowhere. It's a 0 note away from the Ionian node, 0th modal half step. What if I look at this C, for example, still 0 note away, a perfect first. What if I go from this C to this D? Well, that's going 1, 2 notes up, or 2 half steps. You could call that a major second or something, right? So now from there, I could say that I'm going from C to D. This is C to D, which is a distance of you might call it a major second. So a major second. But you can also call it by color. We're going from yellow green to spring green, and it's going to be going a distance of chartreuse, I believe is the distance here. Now again, that might seem kind of wonky, but you can also see the distances color-wise, and you can actually map out the fretboard with just the distances if you want to, which can help you to map out the interval distances. I'm experimenting with multiple color systems on the fretboard, which again looks very busy, but it allows you to name everything quite specifically on the fretboard. Now this is the same collection of notes that is the 7-note collection around the key of C, but I can pivot the second dimension to be around any perspective of the 7 notes. In other words, instead of measuring it or looking at it from the perspective of the Ionian, we're now looking at it from the perspective of the Dorian node. So the Dorian is now the perfect first, 0 notes away, or flame color. And if I go from the Dorian to the Phrygian, or from the D to the E, that's a distance of 1, 2 half steps, which would be a major second, and that's the one which is now chartreuse from the perspective of the Dorian, right? It's different than up here. So that is something that should be easily able to do. Not easy really in Excel, might be easy in a database program, but I map that out in Excel, and I find it to be very useful in my practice. Anyways, so why this matters for learning. So I really think it's just good to learn like music. I think this will be helpful to anyone to practice, but I really think that these types of things is just perfect for children to learn with, right? This shouldn't, like, music shouldn't be a separate subject in grade school. Music should be integrated, in my mind, to learning math, and then learning intervals, learning basic counting, maps. Basically, we're looking at a map of the territory, spatial visualization, patterns. There's nothing better than music, and then going from there to spreadsheets and computer programming. There's nothing better than the logic of music to do that if we map it out as logically as possible. Not only that, but we can compare and contrast the measurement of music, how the phenomenon works, by comparing it, mapping it onto the way color works, to give us a compare and contrast there as well. So children can see music like a rainbow. So we have the pitch and is the hue. And again, whenever I say rainbow, I feel like I'm being political and stuff. You know, it's the spectrum. So we need to me, we need to depoliticize color, right? And start to say it's okay to look at color scientifically here. It's a scientific thing, phenomenon, and we want to pitch it out. We want to measure it, and then I want to compare and contrast that phenomenon to that of sound. So pitch is going to be equivalent to the hue, color, which we can map onto each other, and then the octaves are going to be lightness, meaning I can add another dimension of lightness, popping it off the page, and then the intervals equal rotation. So this helps reinforce math, circular learning, frequency, doubling. All of these things are just basic things that there's no, again, should be just normal curriculum, and there's no better practical thing to work with than music. Really, I mean, seriously, like, I'm an accountant, and accounting is not as good as music to make an Excel worksheet with. Music is at least as good as debits and credits to make an Excel worksheet. So clarify music structure visually, and create color-coded instruments or sheet music. And again, whenever I say color-coded, I feel like there's some kind of, just because of the political environment I happen to be in California in the United States, I feel like there's some kind of political thing there. It's like, no, the colors are coded to define the notes, right? The notes, they should be given, you should be able to visualize the notes by color. And again, someone that works in spreadsheets and numbers, that's really helpful. If I can visualize whatever I'm looking at and look for the color, if I can get to the point where I actually can see color on the fretboard because I've got it so in my mind, right? That's where I think you could get it, particularly if you're young and people and colors being presented properly to be used for proper associations. So final thought, the pitch wheel and color wheel may not be identical, but they are mathematically analogous, and that's more than enough to make this a revolutionary way to teach music and science together. So again, I just want to point out, final thought here, that you will see stuff out there that says like, well, color is the exact same thing as pitch, and it's a one-to-one relationship, and they're in the same phenomenon that we're taking almost like a spiritual thing as well, and which has some truth to it, a lot of truth maybe, but then they take it too far, right? And so we have to watch out for that kind of thing too. How do you do that? Well, you break it down more systematically so we actually know what's going on, right? So if you compare and contrast the two phenomena, then the better you could do that, the less likely you're going to get into these wonky kind of things that kind of take things too far in whatever direction they're going in, for whatever reason they're going that direction.